Component Writing, Part 1. First in a three-part series covering component writing in Delphi. This article originally appeared in Delphi Developer Copyright Pinnacle Publishing Incorporated. All rights reserved. This first part demonstrates some of the best approaches to building components, and at the same time provides tips on deciding on the best base class to inherit from, using virtual declarations, the process of overriding, and so on. The first two things to ask yourself are why you should make use of component writing, and when you should need to write a component. The first question is easy to answer. In fact, it has many answers. Ease of use. Encapsulated code means that you can simply drop the same component onto various forms again and again without writing a single line of code. Debugging. Centralized code makes it easy to repair an entire application, or set of applications, by fixing an error in a single component and recompiling. Money. There are a lot of companies that are only too happy to pay for the privilege of not reinventing the wheel. The second question is not too difficult to answer either. Whenever you find yourself having to write the same code more than once, it is a good idea to write a component, especially if the code performs differently based on given parameters. How components are created. The first step is to decide which base class you need to derive your component from. When you derive from another class, you inherit property/method and event that component owns. Below is an example of how to decide which class you should inherit from when writing your own component. Click for full view. In the case of method A and method B, presume that the component in question is tmemo. Method solution A derived from tmemo, B derived from tCustomMemo, C derived from tCustomControl, D derived from tGraphicControl, E derived from tComponent. This may seem a little complicated, so let me explain the process. A. When you simply need to add extra functionality to an existing component, you derive from that component. This will automatically give your new component all of the existing functionality and properties of the existing component. B. Sometimes you not only need to add functionality, but you need to remove it at the same time. The standard practice when writing a component is first to write a tCustomXXXXX component where all of the properties/events and methods are declared within the protected section of the component. The actual component is then derived from this base class. The trick therefore is not to hide functionality, but to derive your component from the custom version of the component and only publish the properties you want to keep, effectively removing unwanted properties/events. C. Any component that needs to receive focus needs a window handle. Twin control is where this handle is first introduced. T-custom control is simply a twin control with its own canvas property. T-graphic control does not have a window handle and therefore cannot receive focus. Components such as T-label are derived from this base class. Some components are not created to enhance GUI interactivity but to make your life easier. Anything derived from T component is only visible at design time. A typical use of this type of component is for database connections, timers, etc. Once we have decided what our base class should be, the next step is to create the component. From the component menu, select New Component and you will see the following dialog. Ancestor type. This is the base type that we need to descend from. Class name. This is the class name of our new component, prefixed with the letter T. Palette page. This is which tab on the component palette you would like your component to appear on. Entering a non-existent tab will tell Delphi that you would like a new tab created. Writing some code already. It is time for us to write something. This first example will have no use at all except to demonstrate some basic concepts of component writing. First of all, select Component from the main Delphi menu and then select New Component. Enter T component as the ancestor type and T first component as the name of your component. Next, click the Install button. At this point you may either install your new component into an existing package. A package holds a collection of components, or install into a new package. Click into New Package and click the Browse button. Once you have selected a path and file name for your new package and entered a description, click OK. At the next dialog, asking if you would like to recompile your package, click Yes. Once the package is compiled and installed, save your package and unit. At this point we have specified our base class, and also our new class name. We have created a new package to contain our component and have been presented with a skeleton class structure by Delphi. If you look at the source code provided by Delphi, you will now see the private, protected, public, and published sections. Encapsulation. Encapsulation is a simple concept to grasp, but extremely important to component writing. Encapsulation is implemented with the use of 4 reserved words: private, protected, public, and published. You will see the Delphi has included these sections automatically in the source code for your new component. Section Accessibility. Private methods, properties, and events declared within this section will only be accessible to the unit the component is contained within. Components in the same unit can access each other's private items. Protected methods, properties, and events declared within this section will also be accessible to any class descended from this class. Public methods, properties, and events declared here accessible from anywhere. Published. This section allows you to declare properties/events that will appear in the Object Inspector. These settings are design time values that are saved with your project. Not all types are supported. Arrays, for example, are not. Starting to write our component, Delphi now needs to know all about our new component. Enter the following code into the component source code. Private declarations f_start time, f_stop time dword. Protected declarations function get elapsed time, string, virtual. Public declarations procedure start, virtual. Procedure stop, virtual. Property start time dword read f_start time. Property stop time dword read f_stop time. Property elapsed time, string read get elapsed time. Published declarations end. What we have done here is added two variables f_start time and f_stop time. It is standard to precede variable names with the letter F. There are two methods for controlling these variables, start and stop. We have added a getElapsedTime function which will return f_stop time, f_start time as a string. Finally, we have added three read-only properties. Press Shift-Control-C and Delphi will automatically complete the code for your class, or click the right mouse button and select Complete Class at Cursor. Next, enter the following code for each respective method. tFirstComponent function tFirstComponent.getElapsedTime, string, begin result equals into str, f_stop time, f_start time, and procedure tFirstComponent.start, begin f_start time equals getTickCount, and procedure tFirstComponent.stop, begin f_stop time equals getTickCount, and test drive. Save your unit, and reopen your package, File, Open Project from the menu, and select Delphi Package for the file type. Once your package is open, click the Compile button. You can also open your package by choosing Component from the main menu and then Install Packages. Select your package and then click the Edit button. You can now drop a tFirstComponent onto a form. In fact, you can drop as many as you like. Add two buttons, btn start and btn stop, and add the following code to your form, and then run your test app. Procedure tform1.btn start click, sender, tObject, begin first component 1.start, and procedure tform1.btn stop click, sender, tObject, begin first component 1.stop, caption equals first component 1.elapsed time, and clicking the start button will mark the start time. getTickCount is a WinAPI command that returns the number of milliseconds since Windows started. Clicking the stop button will mark the stop time, and change the caption of the form. Virtual, dynamic, abstract, and override. You may have noticed the virtual declaration after start, stop and get elapsed time. The following exercise will explain their uses. Create a new component. Derive this component from tFirst component, name it tSecond component, and install it. The virtual and dynamic identifiers are a component writer's way of telling Delphi that the method may be replaced in a descendant class. If we override a method in a class, our new code will be executed instead of the original code. Protected declarations function get elapsed time, string, override. We then implement the above code as follows. Function tSecond component .get elapsed time, string, var s, string, begin s equals inherited get elapsed time, result equals s plus milliseconds or plus format, %.2f seconds, stop time, start time, /1000, and our new code is now called in replacement of the original get elapsed time. Even calls implemented in tFirst component to get elapsed time will now call our new code. If we have created an instance of tSecond component, that is, the original code is invoked through the use of the inherited command. Note, if you do not override a base method, because the base was not declared as virtual or because you forgot, tSecond component will call your new code, whereas any code implemented in tFirst component will still continue to call the original code from tFirst component. The abstract identifier tells Delphi not to expect any code for the named method. You should not create an instance of any object with abstract methods in them, such as tstrings. The standard practice is to create a descendant of such a class and to override all abstract methods, such as tStringList does. Dynamic vs virtual is simply a question of speed vs size. A dynamic method will result in each instance of a class requiring less memory, whereas a virtual method will execute faster at the cost of a little extra memory. There are a few simple steps to adding events to your component. Events allow the component to communicate with your application, to notify it when something important has happened. An event is merely a read/write property, instead of being a simple variable type, such as string, integer, etc. It is a procedure or function. Create a new component, descend it from t2nd component and name it t3rd component. Save the unit, install your component, and add the following code. Type tstate equals st_started, st_stopped, tstate change event equals procedure sender, tObject, state, tstate, of object, t3rd component equals class, t2nd component, private declarations fstate, tstate, onStart, onStop, tNotify event, onStateChange, tstate change event, protected declarations public declarations constructor create, owner, tComponent, override, destructor destroy, override, procedure start, override, procedure stop, override. Property state, tstate read fstate, published declarations property onStart, tNotify event read onStart write onStart, property onStateChange, tstate change event read onStateChange write onStateChange, property onStop, tNotify event read onStop write onStop, and events are simply procedures or functions, rarely, that belong to a class, hence the of object clause you see in the tstate change event. For example, tNotify event is a standard event type implemented by Delphi which just passes the object that triggered the event. It is always good to send self, sender, tObject, as the first parameter of any event, as the same event code may be used for multiple components. tNotify event is defined as type tNotify event equals procedure, sender, tObject, of object. To call an event from within a component is just a case of checking if the event has been assigned and, if so, calling it. I have overwritten the start and stop methods of t2nd component in order to trigger these events, like so. Procedure t3rd component .start, begin inherited, / this calls t2nd component .start fstate equals st_started, if assigned, onStart, then onStart, self, if assigned, onStateChange, then onStateChange, self, state, and procedure t3rd component .stop, begin inherited, This calls t second component dot stop f state equals st stopped, if assigned, on stop, then on stop, self, if assigned, on state change, then on state change, self, state, and constructor t third component dot create, a owner, t component, begin. Inherited, / this is where you initialize properties, and create / and objects your component may use internally f state equals st stopped, and destructor t third component dot destroy, begin / this is where you would destroy / any created objects inherited, and recompile your package. Don't forget to save your package anytime you add a new component. Upon dropping your new component on the form, you will notice that there are 3 events: on start, on stop, and on state change. If you look at Demo 3, you will see how I have used these events. On start sets the caption to started. On stop shows the elapsed time. On state change enables / disables the relevant start / stop button. Procedure t form 1. Third component 1 start, sender, t object, begin caption equals start, and procedure t form 1. Third component 1 stop, sender, t object, begin caption equals third component 1. Elapsed time, and procedure t form 1. Third component 1 state change, sender, t object, state, t state, begin btn start. Enabled equals third component 1. State equals st stopped, btn stop. Enabled equals third component 1. State equals st started, and standards in component writing. Finally, we will cover a few more points about component writing, including some existing methods of base components, and standards for writing. Creating and destroying your component. Objects are created through a constructor and destroyed through a destructor. The purpose of overriding a constructor is threefold: to create any objects that it contains within itself, sub-objects, to initialize values of the class, properties, etc., to raise an exception and stop the class from being created. It is standard to call the inherited constructor from within your own constructor so that the parent class can perform its initializations, although it is not necessary to do so in order to create your component. Your component is created as soon as your constructor is finished. It is not created by calling the inherited constructor. The purpose of overriding a destructor is simply to free any resources that were allocated during the life of component. Call inherited only after you have freed these resources. Standard component parts: paint, You can override this method to provide your own custom drawing of your component. Loaded. This is called by Delphi as soon as all of its properties have finished being set when its parent form is created. You can override this method in order to perform any actions that depend on a group of properties all being set. Invalidate. Whenever a property is changed that affects the visual appearance of a component, you should call this method. Component state. This property is very useful when you need to check if your component currently exists at design/runtime, or if its properties are currently being read by a streaming process. Encapsulating your component properly. It is standard to write your component as T-custom my class and then derive your component from that base class. The custom component you write will have most, if not all, of its properties/methods declared within its protected section. When you descend from your custom class, you simply declare your properties within the public or published sections. Type T custom my class equals class, T component, private F sum string, protected procedure set sum string, const value, string, virtual, property sum string, read F sum string write set sum string, and T my class equals class, T custom my class, published property sum string, and this is good practice as it allows other people to derive their own components based on yours while still allowing them to remove certain properties. Note how set sum string has been declared as virtual within the protected area. This is also good etiquette as it allows descended classes to respond to changes in property values by overriding the procedure that sets them. This also applies to events. Where you see an onState change event, you will often find a doStateChange method. For example, type T custom my class equals class, T component, private F on state change, T state change event, protected.